Hello everyone. Today we will be discussing some questions related to real numbers. We have already made a video on the concept of real numbers. If you have not seen that video, I will suggest you to see the video once so that it will be easy for you to understand how to solve problems related to the chapter. The first question is find LCM and HCF of 144, 112 and 414 by prime factorization. So we all know how to do the prime factorization. First of all, of 144 we will be doing the prime factorization. For that we have taken 144. If we are going to divide it by 2, we will be getting 2 7 is 14, 2 2. So it is your 72. Then again it is divisible by 2. So if we will divide it by 2, it will be 2 3s are 6 and 2 6 is 12. Again we will be dividing it by 2 and we will be getting 2 18 is 36, 2 9 is 18, 3 3 is 9, 3 1 times. That means we can write 144 as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. That simply means 144 could be written as 2 multiplied by 4 times it will be multiplied and 3 will be multiplied 2 times. That means it can be written as 2 raised to the power 4 multiplied by 3 raised to the power 2. This is the prime factorization of 144. Now the another number is 112. If we will do the prime factorization of 112, we can divide it by 2 because it is an even number. So we can divide it by 2. We will be getting 2 5 is 10, 2 6 is 12. Again by 2, 2 2 is 4, 2 8 is 16. Again by 2, 2 1 2, 2 4. Again by 2, 2 7 is 14, 7 1. So the prime factorization of 112, we can write 112 as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7. That means we can write it as 2 raised to the power 4 multiplied by 7. Now we will be doing the prime factorization of 418. That will be divided by 2 because it is again an even number. So 2 2 is 4, then 0, 2 9 is 18. Then it is divisible by 11. 11 1 is 11. 11 9 is 99. 19 is a prime number, so it will be divided by 19 only. So we can write 418 as 2 multiplied by 11 multiplied by 19. So once we have represented all the numbers as the multiple of their prime numbers. Now what we can see over here is we have to find the LCM and HCF. We know that the LCM is product of the greatest powers of all the prime numbers which all are available here. So over here what all prime numbers are there? 2, 3, 7, 11, 19. All these prime numbers are there in the factors of all these three numbers, that is 144, 112 and 418. So highest power of 2 over here in these three, highest power of 2 is here 2 raised to the power 4, here 2 raised to the power 4, here 2 raised to the power 1. So highest power is 2 raised to the power 4. Here if we are going to see the highest power of 3, here it is your 2. There is no multiple of 3. Here even there is no 3. So highest power of 3 will be, it is your 3 raised to the power 2 only. Highest power of 7 is only 7 here. So we will be taking 7 also. 11, we will be taking 11. And then 19, we will be taking this. So multiple of all these. That means highest powers of all the prime numbers coming in the factors. So we'll be taking all these numbers and the product of all these, we can see over here, the product of all these numbers is 210672. That means this will be the LCM of these three numbers. Now we have to find the HCF, and HCF we know it is the product of the smallest power of all the common prime numbers. Here we can see 2 is available in this 144 also. In the prime factorization of 112, we can see 2. In the prime factorization of 418, we can see 2. So 2 is common in all the three factors of your numbers. So we can see the smallest power of 2 over here. Here it is your 2 raised to the power 4. Here it is 2 raised to the power 4. Here it is 2. So smallest power of 2, which is common on all the 3, is your 2 only. So we will be taking as 2. Now if we are going to compare the C is 3. So 3 is available in 144. But 3 is not available in 112, and it is not even available in 418, because 3 is not common in all the 3. So for HCF we won't be considering it. Now 7 is even available in 112 only. It is neither in 144 nor in 418. So we won't be considering 4 even, 11 even and 19 even, because they are not available in all the 3 factors. That's the reason HCF will be 2 only. So this is how we can find the LCM and HCF of the given numbers. One more relation is even there if only 2 numbers are there. Here though it was 3 numbers were there. It is your 144, 112 and 418. If there are only 2 numbers, so one relation we had studied in your video of the real number, that is if there are 2 numbers A and B, then HCF of these 2 numbers multiplied by LCM of these 2 numbers, it is equivalent to product of the numbers. That means if only 2 numbers are given and we have to find the LCM and HCF, sometimes these type of questions are even asked that HCF of these 2 numbers is this and the numbers are this and this. So what will be the LCM? So using this relation, we can find the number. If LCM and HCF both are given of numbers and one of the number is given, we can find another number using this formula. But this is not applicable for 3 numbers. It is only applicable for 2 numbers only. Here is another question. Prove that 2 root 3 plus root 5 is an irrational number. Also check whether 2 root 3 plus root 5 multiplied by 2 root 3 minus root 5 is rational or irrational. So whenever these type of question comes that we need to prove this as a rational number, what we do is we assume it to be rational. We are assuming let 2 root 3 plus root 5 is a rational number. And if this is a rational number, we know that rational numbers are the numbers which can be represented in the form of P upon Q, where Q is not equivalent to 0. So we are assuming this to be a rational number. So either we can assume it to be equivalent to A, which is a rational number, or we can take it as P upon Q also. So either we will be taking 2 root 3 plus root 5 is equivalent to take it as P upon Q only, P upon Q, where Q is not equivalent to 0 and P and Q are any integers. That means it is a rational number that we are assuming. That 2 root 3 plus root 5 is a rational number, and if it is a rational number, we know that it can be represented in the form of P upon Q. Now if this is the case, so we can say 2 root 3 is equivalent to P upon Q minus root of 5. This plus root of 5, when it is going to change the direction, it will become minus root of 5. Now squaring both the sides, it will be 2 root 3 square. It is equivalent to P upon Q minus root of 5 whole square. We have squared both the sides. So square of this will be 2 root 3, that is 2 multiplied by 2, 4, and root 3 into root 3 will be 3. So 4 3s are 12. So square of 2 root 3 will be 12. It is equivalent to, it is your A minus B whole square. Now if it is A minus B whole square, its expansion will be A square plus B square, that is root of 5 square, that is your 5 only, minus 2AB, that is 2 root 5 P upon Q. It will be the square of this whole, that is P upon Q minus root 5 whole square will be A square plus B square minus 2AB. Now if we are going to take this term over here in the LHS part and this 12 over here, so this will become 2 root 5 P upon Q. It is equivalent to P square upon Q square plus 5, and this plus 12 will go over here, will become minus 12. That simply means it will be P, this can be written as 2 root 5 P upon Q. It is equivalent to P square upon Q square plus 5 minus 12 will be minus 7. Now, if we will be solving it further, this part only I am taking right now. So it will become q square, and this is your p square minus 7q square. This is equivalent to your 2 root 5 p upon q. Now, if this is equivalent to this, we can say root 5 will be equivalent to this 2p will go in the denominator and this q will go over in the numerator. So it will be q over 2p multiplied by p square minus 7q square over q square. What we have done is we have taken just root 5 we have kept in the left hand side. Rest all the terms we have taken in the right hand side, because we want root 5 only to be here in the LHS part, rest all to be in the RHS part. So this q was in the denominator, so we have taken it in the numerator. This 2p was in the multiplication, so we have taken it in the denominator. Now this was taken as it is. Now we have seen already that p and q are any integers and q is not equivalent to 0. That means if we know p, q, 2, 7, all these are your rational numbers, and if all these are rational number, that simply means this will even be a rational number, because over here what all terms are coming? 2 is coming, 7 is coming, p is coming, q is coming, and all these are rational numbers. And if we will multiply, divide, or plus or minus, whatsoever we do of the rational number, the answer is even a rational number only. That means this is a rational number, and we know that root 5 is a irrational number, and a rational number cannot be equivalent to a irrational number. If suppose this is your equation number 1, so from this equation what it concludes, that a rational number is equivalent to a irrational number, which is practically not possible. That means why this contradiction has arisen? Because of our wrong assumption, and that means our assumption was wrong. It is basically a irrational number, it is not a rational number. All this thing we need to write, that this contradiction has arisen because of our wrong assumption, and basically it is not an rational number, it will be a irrational number. So this is how we can prove these type of questions. Now the second part of the question is also check whether 2 root 3 plus root 5 multiplied by 2 root 3 minus root 5, whether it is a rational number or irrational number. So here we can see it is your a plus b, a minus b, where a is your 2 root 3 and b is your root 5. So identity for a plus b, a minus b is a square minus b square. That simply means if we are going to expand it, it will be equivalent to a square minus b square. The square of 2 root 3 will be 4 multiplied by 3, that is 12, and square of root 5 will be 5. That is equivalent to 7, which is a rational number. That means the product of these two irrational numbers is a rational number. We have proved it, and this is how it will be proved. Now let's see the third question. Three numbers are in the ratio 1:2:3 and their HCF is 12. Find the positive square root of largest number. So we know that if there are three numbers and the ratio of the three numbers are 1:2:3, that simply means that the numbers are not 1, 2 and 3. Their ratio is 1:2:3. That means if this is the case, we are assuming let the numbers be x, 2x and 3x, because if we are going to take these three as the numbers and if we are going to take their ratios, it will be 1:2:3 only. Now these three are the numbers. If we are going to do the prime factorization of these numbers, we can see that x could be written as x only. Prime factorization of 2x could be written as 2 multiplied by x, and prime factorization of 3x could be written as 3 multiplied by x. If we are going to see the prime factorization of all the three numbers, we can see that the HCF of these three numbers will be x. What HCF is, just now we had discussed that HCF is the smallest power of the common prime number available over here in all the three numbers over here. If there are three numbers are here, one is x, another is 2x and 3x, and if we are going to see their prime factorization, the smallest power of the common number is the HCF. Over here 2 is not common in all the three. 3 is not common in all the three. Only common is your x, and the smallest power of this x over here in all the three numbers is your x only. That simply means HCF of these three numbers will be x. And in the question it is given that HCF is 12. That means value of x is your 12. Hope it is clear till now. And if the value of x is 12, one of the number will be 12. The number which was x will be 12. The number which is 2x will be 2 multiplied by 12, that is 24. The number which is 3x will be 3 multiplied by 12, that is 36. So the numbers are your 12, 24 and 36 are the numbers. Now the second part is find the positive square root of largest number. Out of these three, largest number is 36 and we have to find the square root of it. So square root of 36 we know it as plus minus 6, but we have to take only the positive square root of the largest number. That means required number is your positive 6. Required number is 6 only. So this is how we can solve these type of questions. The questions which we have taken, which we are discussing, are the most of the time these type of questions are asked in the board examination. So whatsoever type of questions comes, we are practicing that type of questions only. Let's see one of the word problem. Anita, Suneha and Rajiv start preparing cards. In order to complete one card, they take 10, 16 and 20 minutes respectively. That means in order to complete one card, Anita is taking 10 minutes. Suneha is taking 16 minutes. And Rajiv is taking 20 minutes. In order to complete one card, they are taking this much of time. If all of them started together, after what time will they start playing a new card together? See, so Anita is completing one card in 10 minutes. That means after 10 minutes, she will start preparing for the another card. And she will complete it in 20 minutes. After 10 minutes, she will be completing. Then again after 10 minutes, she will be completing. Then again after 10 minutes, she will be completing like this. Now Suneha is completing one card in 16 minutes. That means one card she will be completing after 16 minutes. Another card she will be completing after 32 minutes. 16 multiplied by 2 or 16 plus 16 we can say. Then again 16 to 30 or 16 threes are 48 minutes. Like this she will be completing the cards. Now if Rajiv is completing one card in 20 minutes, that means second card he will be completing in 40 minutes, then 60 minutes, so on. Now we have to find when they will start playing a new card together. Anita is playing after every 10 minutes, Suneha is playing after every 16 minutes and Rajiv is playing after every 20 minutes. So whensoever they will start playing a new card together, that will be the multiple of these three numbers. Then only they will start playing together. That means we are finding the multiples of these. Whensoever all of their common multiple will be there, that will be the required answer. That means we have to find the LCM. Least common multiple of all these three numbers is the thing which is required to us. So how we can find the LCM of 10, 16 and 20 we need to find. For finding the LCM of these three, 10, 16, 20, we can find like this. 2, 5 is 10, 2, 8 is 16, 2, 10 is 20. Then again 2, 5 is not divisible, so we will keep it as it is. 2, 4 is 8, 2, 5 is 10. Then again by 2, 5, 2 2s are 4 and then 5. Again by 2, 5, 1, 5. Now it will be divisible by 5, 1, 1 and 1. So the LCM of these three number will be 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5. That means 2 to 4 to 8 to 16, 16, 5 is 80. After 80 minutes, all of them will start playing together. Now let's see. 10, 20, 30, 40, 50, 60, 70, 80. 16, 32, 48, 16, 4 is 64, 16, 5 is 16, 32, 48, 16, 4 is 64, 16, 5 is 80. 20, 40, 60 and then 80. That means this is the common multiple of all these three numbers, and after this much of time they will start playing together. So in these type of questions we need to find LCM of the given numbers. Now let's see another word problem. 3 sets of English, Hindi and Maths books have to be stacked in such a way that all the books are stored topic wise. That means 3 types of books are there, 3 subject books. One is of English, one is of Hindi and one is of Maths. And they have to be arranged in topic wise. That means in one stack only one subject books will be there. We won't be mixing 2 subject books together. In one stack only one type of books would be there. And the height of each stack is same. That means in one stack, whatsoever the number of books is coming in one stack, in the second stacks will be the same number of books will be there. That means in every stack, the number of books will be same. The number of English books is 96. Total number of English books is 96. We have to arrange 96 books in different stacks. And total number of Hindi books is 240. And total number of Maths book is 336. Each book has same size. The size of all the books is same. That means if we are arranging 10 books of Hindi in one, 10 books of English in one stack and 10 books of Maths in one stack, the height will be same in all the 3 cases. Determine the number of stacks of English, Hindi and Maths books. So first of all, we have to find out that in one stack, how many books will be arranged. That number of books will be the multiple of your factor of 96 also, should be the factor of 240 also, and should be the factor of 336 also, because it will be, if it will be the factor of this, that means suppose I am saying that if number of books over here arranged is suppose 20 in one stack, that means if 20 is arranged in one stack, so in another also it will be 20, in another also it will be 20, but in every stack it should be equal, right? That means 20 should be the factor of all the 3 numbers, then only it is possible to arrange in every stack 20. That means whatsoever the number is asked, we have to find is the HCF of the given numbers. That means the highest common factor of all the 3 numbers will give us the number of books in one stack. In one stack, how many books will be arranged? It will be given by finding the HCF of the given numbers. Now, if we have to find the HCF of the given numbers, first of all, we have to find the factors of all these 3 numbers, prime factorization method. So, 96, if we are going to prime factorize it, 2, 2, 4 is 8, 2, 8 is 16, 2, 24, 2, 12, 2, 6 times, 2, 3 times, 3, 1 time. So, 96 could be written as 2 multiplied by 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 3. That is 2 raised to the power 5 multiplied by 3. 96 could be written as 2 raised to the power 5 multiplied by 3. If we are going to see for the 240, the prime factorization of 240, we will check. So we will divide it by 2 once. 2 1 is 2, 2 2 is 4. Then again 2 60 times. Then again 2 30 times. Then again 2 15 times. 3 5 times. 5 1 time. So 240 could be written as 4 times 2 is coming. So we have taken 2, then 3 and then 5. That means 2 raised to the power 4 multiplied by 3 multiplied by 5. Now we will be doing the prime factorization of 336. It is again an even number. So could be divided by 2. 2 1 is 2. 2 6 is 12. 2 8 is 16. Then 2. 2 8 is 16. 2 42 times, 2 21 times, 3 7 7 1. So 336 could be written as 2 is coming 4 times, that we have written, then 3 and then 7. That simply means 2 raised to the power 4 multiply by 3 and multiply by 7. Now for finding HCF, we have to take product of the smallest power of all the common prime numbers. Here, the prime number over here, 2 is common in all the three. 2 is here also, 2 is here also, 2 is here also. So here the smallest power of 2 in all the three is 2 raised to the power 4. Here 2 raised to the power 4, here 2 raised to the power 4, here 2 raised to the power 5. So smallest power of 2 is 2 raised to the power 4. Now we can see 3 is also common in all the three. That means the smallest power of 3 over here is 1 only. So we will be taking 3 also. Now 7 is not available in all the three. 5 is even not available on the 3. That's why we will be ignoring it. So HCF of all these three numbers will be 2 raised to the power 4 multiplied by 3. 2 raised to the power 4 means 2, 4, 16. 16 3s are 48. So 48 will be the HCF of these three numbers. That simply means in one stack, 48 books will be arranged. Now, if we will be arranging 48 books in one stack, so how many stacks will be required for 96 books? That means for English, total number of stacks required for English is total number of books is 96, and in one stack we can arrange 48 books. So total number of stacks required will be 96 divided by 48, that is 2. That means in 2 stacks all the books of English will be arranged. Now there are total 240 books of Hindi. Now if in one stack we are arranging 48 books, so for Hindi how many stacks are required? Total number of books is 240. And we have to arrange this in number of stacks, and in one stack 48 books are we can accommodate. So it will be 5 stacks will be required. For maths, total number of books is 336, and we know that in one stack 48 books could be arranged. So 336 divided by 48. So it will be 7 number of stacks will be required. So for arranging all the books of English, 2 stacks will be required, and in every stack, total number of books will be 48. Whether it is of English, whether it is of Hindi, or whether it is of maths, in one stack only one type of subject books is there, and total number of stacks required for all the 96 books is your 2. Total number of stacks required for 240 Hindi books is 5, and total number of stacks required for 336 books of maths is your 7. So this is how we can find it out, and in these type of questions we have to find the HCF, that is your highest common factor. So these type of questions are generally asked in the board examination. Hope it is clear to you. Soon we'll be coming with more questions of other chapters also. If you have not yet subscribed my channel, please do subscribe it. Thank you.